Welcome everyone. Today we'll be discussing GATE Solution 2026 Part A 1 marks question. Okay, Part A 1 marks. In previous videos we have discussed image processing 1 marks question, image processing 2 marks question, and aptitude. One video is there and that 1 plus 2 marks both are there. So 45 marks we have already discussed. Now we will discuss part A 1 marks questions. Okay, and next video will be part A 2 marks question and then surveying. Okay, so let's start with question 11. So in every question detail I will not be going behind theory. I will just tell you the solution and how means little how to solve, background, more background we are not going. Okay, so which one of the following option influences the pixel size of an image obtained from a whisk room optical remote sensing sensor? So pixel size, how it is influenced by which factor? Okay, so here directly you can solve how I am telling. So you remember GIFOB and pixel size, there is relation, like if less than or greater than, we have undersampling occurs and oversampling occurs. So this is the one condition. So anyway GIFOB doesn't influence pixel size, because if it is less than or greater than, then we have two condition. So GIFOB both option will be cancelled, and ground projected field of view is in, like, not pixel, the combination of pixels in one go, how much area is observed, that is called ground GFOV. Okay, so this also will not be offset. So what is happening? So electronic signal from detector will be sampled for delta t. Okay, and this, in this delta t, how much distance will be covered? Okay, that is pixel size. Okay, so this is the option. Now coming to question 12. So 12 question was very direct. Standard FCC. So in a standard FCC we know, like, NIR goes to red, red goes to green, and green blue. So this is the condition. Okay, so this is NIR to red, so only this option, yeah. So this will be the answer, and this is why vegetation occurs red. Okay, in FCC, because vegetation strongly reflects NIR. Okay, so by that logic also you can remember. So this was very direct question. Now moving to question 13. So swirl and cloud, actually, it reflect, okay, swirl not, means actually this is answer. So cloud and snow, so both are white. So what happens? Almost everything it reflects in visible region. Okay, so if you see most of the, what is our visible region? 0.4 to 0.7. So both have same property in that. So this and this, anyway this will not be answer. Okay, and in NIR region also, uh, both both reflect strongly. So NIR region also and red region also, that happens. So anyhow this also will not be answered. So swir in soil it is possible to distinguish between both because snow absorbs, and that means snow has less reflectance in that, and cloud has relatively more. Okay, so this will be the answer. Okay, so 13 answer is A. Now coming to question number 14. So question number 14, the length of a highway was measured in 10 equal section. So this is a highway. So like this, 1, 2 till 10 is there. Okay. If the precision of individual section measurement is sigma, then what is the precision of measured length of highway? So total. So this precision doesn't remain constant. Uh, we have discussed in engineering math classes. So what happens? Variance we can add, not sigma we can't add, variance we can add. So like this for 10. Okay, so 10 sigma square will be the sum for highway. Okay, so total variance is 10 sigma square. Okay, and we have to find precision, that is standard deviation. So how much it will be? Root of 10 sigma square. So that is sigma root 10. So this will be the answer. Now moving to question 15. Okay, so in GNSS positioning, the dilution of precision is good indicator of. Okay, so we have discussed this question before also in our theory classes. So what happens? Satellite geometry like DOP is related to satellite geometry because when it is well distributed, when satellite is well distributed in the sky, we call good DOP, and when it is not well distributed, we we call it as low DOP. Okay, so it is about satellite geometry. Okay, dilution of precision, good DOP and bad DOP, that is about satellite geometry. Now question 16. Actually question 16 doesn't require your RS and GIS knowledge. This question is about unit and dimension of, we read it in class 11 or 12. Okay, class 11 this syllabus is there, unit and dimension chapter. Okay, what we do, so we know phi they have told it is in cycle. Okay, so left hand side is cycle. Now we can add same units. Okay, so anything this will be in cycle. So now they are asking for delta ino or delta tropo. This is not, delta doesn't mean displacement here. Okay, so what they are telling, f into delta ino. Delta ino is something we don't know what it is. Okay, so but we know what f is. They have written in question, f is frequency of carrier in hertz. Hertz means, hertz is cycle per second. Okay, so this f is cycle per second, and you have left hand side cycle. So what you will multiply, that it remains cycle. So if this unit is second, both will get cancelled and cycle will be equal to cycle. So this has to be second. Okay, so unit and dimension you should equate. Okay, just that. So this question also second is answer. Now moving to question 17. Okay, so in GNSS positioning, the cycle slips are the most detrimental for estimating. Okay, so what they are telling, this cycles. Okay, so we have read this like Okay, so this is one cycle. So when we receive signal, we don't know how much cycle it has occurred. We know the phase. Okay, phase we know, but number of cycles we don't know. So this number of cycle, that only cycle slips they are telling, that we don't know. There is one cycle, two cycle, or means suppose x cycles plus 1 2 anything, that number of cycle is a problem. So what is that number of cycle being problem is integer ambiguity, that we don't know the number of cycles, so that only is called integer ambiguity. So answer is 17, answer is A. Okay, now coming to question 18. Okay, so which one of the coordinate pairs present the satellite orbit in a sky plot of the GNSS constellation? Okay, so here this is direct question, like we know there is elevation is required, like every satellite we denote it in GNSS class we have discussed, like elevation is required to know, means to derive anything for satellite, elevation is must. And then if you see elevation, if you know, then after that you can have confusion. Here there are two angles only, so only this option was confusing, and other than that any one angle will be enough, like azimuth or zenith angle. So elevation is must, and one among azimuth and zenith angle will be enough, but here option is like that, that elevation and azimuth we can choose here. Okay, so question number 18, A will be the answer. Okay, coming to 19. So 19 question is teen, tiny graphic polygons. So what are tiny graphic polygons? These are like small unwanted polygons created due to boundary mismatches. Okay, so uh, these are a small boundary, small polygons unwanted that are created due to boundary mismatch. So those are silver polygon. Okay, so tiny graphic polygons are silver polygon. Then open polygon. So open polygon has edges that don't properly close. Okay, so this creates a dangle. Okay, and overshoot or undershoot also, what happens, line extending beyond or falling short of intersection, and this create dangling arcs. Okay, so that also is dangle. And polygon with inadmissible loops, so this creates topologically invalid polygon shapes. Okay, and these are called weird polygon. So we can match P. For P it is 1, so this 2 cancel. Q and R it is 2. Okay, so S 3. So A will be the correct answer. Now coming to question 20. So buffering operation on point or line results in, so suppose you have point, then equal distance buffer, this circle will be created. So if you have line and you are taking rectangle type, then this type it will be created, or it may be this type also, depending on what you choose. In QGIS, suppose if you are doing, you have the option to choose. So this is polygon. Okay, so 20 option will be A. Now coming to 21. So 21 is which is are the correct option that indicate multispectral sensor. Multispectral. So multispectral, we know, like many satellites are there, like Landsat, Sentinel, Moody's. These are all multispectral. Okay, so a sensor with 10 non-contiguous spectral band having a bandwidth of about 0.04 micrometer. So 10 non-contiguous. Okay, so this is one multispectral. property. Now 25 256 contiguous with bandwidth of 5 nanometer. So when there is very small bandwidths and contiguous bands, those are mostly hyperspectral. So this is one hyperspectral, and single band is not, of course, multispectral. So this option is also not there. And again, contiguous and very low bandwidth, that is hyperspectral. So only option is A. Now coming to question 22. Which of the following is a topological relationship element in GIS? So adjacency is one of the feature, and that is like adjacency features sharing boundaries. Okay, sharing boundaries. So this is one topological relationship. Then connectivity. So features are connected through nodes or edges. Okay, this also is one of the property. Now containment, one feature inside another. Okay, and intersection is a intersection is a type of operation, a special operation, but not topological element. Okay, so A, B, C will be the answer here. Okay, so this is actually memory based question. Which of the following is are preserved in Mercator projection? So in Mercator projection, shape and direction are preserved. Okay, area is not preserved. Okay, and like shape only along the standard parallel. So this happens in conformal projection. So for this, only these two will be the correct answer. Okay. Now coming to next question. Which of the following options are correct in the context of line area spatial relationship? So which are valid always, like that they are asking. So suppose this is an area. So line is contained in area. This can be true. Okay. Line crosses an area. This only we extend. That will be the also true. Line is parallel to area. This may not be always true because line can be this. Okay. Or suppose here also line can be like this. So anything, and line is nearest to area. This is also like ambiguous statement, means nowhere related also. So only these two are related. So these two are correct. Now question 25. So okay, I will not draw again. Here itself I am explaining. So in triangulation network shown in the figure, B and G are the observed baseline. Okay, where while 1 to 18 are observed interior angles. So 1 till 18, 1 2 3 like this till 18. The number of redundant observation means more observation than required. How much it is? Okay, more observation, by what that I mean is, for drawing a triangle, if you have one angle, two angle, and one side, that side means this length, that will be enough. Okay, so other than this, if we are measuring this also, this also, this also, so three measurements were enough, and other three are redundant information. Okay, these are not required extra information. Okay, so now let's start from here. So triangle 1 needs one baseline. Okay, and two angle. Okay, so here it will be 3, and for second, one baseline is fixed from before. So two angles itself will do, like that we can triangle 2, triangle 3, means triangle 3, triangle 4, triangle 5. This all will require only two information. Okay, so this two, this two, this two. Okay, now this also 2. So total will be 3, 5, 7, 9, 11, 13. So 13 are required. But how much we have? 18 angles we have, and 2 length also we have. So total 20 we have. So extra information is 7. So 7 will be the answer. Okay. So that's all for this. Coming to question 26. So question 26 was more about understanding the definition. So suppose this is a normal distribution curve. So what happens? Suppose this is x and this is probability distribution function. Okay, PDF. So this is PDF f of x. Okay, not, this is not probability, this is probability distribution function. So in probability distribution function, what happens? Probability is area under the curve. Okay, so suppose this is A and this is B. So from A to B, whatever will be the area under curve, that will be the answer for probability. Okay, but here it is asked for a particular point. So now we have at this point what will be the probability. So in continuous random variable, at a point probability doesn't mean anything, so answer will be 0. Okay, if they would have asked from one point to other, we will have some answer, like from 0 to mean. If they would have told or something like that, then we could have told it is 0.5. Okay, but question was for one point itself, so that answer is 0. Now coming to consider a random experiment of rolling a fair die. The probability of getting an odd number or a number less than 4, odd number or less than 4. Okay, so let's, here we can make itself direct. So 1 2 3 4 5 6, these are the 6 options we will be getting. So less than 4, so these all are less than 4. Okay, so this is one statement. Probability of getting an number less than 4 is this, or odd number is also valid. So this also can come. So what is the probability of getting this 4? So our, what is our probability? 4, and total sample size 6. So 4 by 6 is 0.66. So only this 2 is actually not allowed. Okay, so 0.66, 0.67, anything you can mark. Okay, so okay, so that's all for 1 marks question. Now in next video we will discuss about 2 marks question. That's all. Thank you.